We're going to look at some strengths and weaknesses of each method of solving linear or systems of equations. And we're going to talk about when you should and shouldn't use some and why you should use some as opposed to others. So when we say applying systems of linear equations, we're really saying which method should we use when. So let's talk about each. Graphing. So when we talk about graphing, we are going to really only use this if both equations are in slope-intercept form, or y equals mx plus b, but not even just then, but also if it'll make a clear intersection on a point on the graph. So that we don't want to have to graph these to find out that, it intersects in between 2 and 3 and 3 and 4 and have to estimate. That wouldn't really be efficient. What we'll want to do is use another method if it comes to that. Because quite frankly, this is the least used method. And again, we could see this if we had y equals x plus 3 and y equals negative x plus 3. If it was something that we know would intersect nice and easy while graphing, then we would use it. When would we use substitution? We could use substitution if one equation is solved for one variable already. So think if we have like x equals something or y equals something, or if we have one variable with a coefficient of either positive or negative 1, because then we can really rearrange it to like be, if we have something where it's with one step, we can make it x equals something. That'd be super easy to substitute. Be careful that you don't get too busy with your work, I guess we'll say. Don't try and substitute for something if it's just going to make the work harder. So for example, if we had x equals 2y plus 3 and 3x plus 4y equals 7, that would be a good time to substitute. A bad time to substitute would be if you have to make fractions and just make things really tricky. Elimination, when are we going to use elimination? Quite frankly, most of the time. Elimination is really kind of the surefire way that you're going to be able to solve these systems of equations at any time. Careful when we're adding that it's already opposite. Careful when we're doing more adding and we have to multiply by a negative 1. And when we actually have to multiply at least one equation to get opposites. So just be careful with elimination. You are going to use that most often, but make sure you're doing it correctly. For your practice problems tonight, we are on page 882, 1 through 11, but we're skipping number 5. 1 through 11, but we're skipping number 5. So we're going to look at the directions, which say determine the best method to solve each system of equations and then solve. So basically your directions are solve. Pick the method you think works best. So for 1, we see 2x plus 3y equals 11 and negative 8x minus 5y equals 9. Are they both in slope-intercept form? Probably not going to graph. Is one equation solved for one variable and then therefore you can substitute it in easily? Not really. So we're probably going to use elimination. And a hint, I would start by multiplying this top equation by 4 and go from there. Have fun. Use the other videos from 6-1, 6-2, 6-3, and 6-4 for help. Rewatch some of those videos, take a look at some of those notes, and you can do this.